Okay, number 1 says, what are the complex solutions to the following equation? And the equation is negative 3x squared plus 2x minus 3 equals 0. And to solve this, you're going to use the quadratic formula, and that is opposite of b plus minus square root b squared minus 4ac divided by 2 times a. And now we're just going to plug these numbers into the equation. So we're going to label these a, b, and c. Okay, and so opposite of b, opposite of 2 will be negative 2. So negative 2 plus or minus 2 squared, since 2 is b, minus 4 times negative 3 times negative 3. Those are a and c terms, divided by 2 times negative 3, which is the a term. Okay, so now if we plug all these in, we get negative 2 plus or minus the square root of negative 32 divided by negative 6. Okay, and you get negative 2 by multiplying, or doing 2 squared. And when you do 2 squared, you get 4. And then you multiply negative 4 times negative 3 times negative 3, and you get negative 36. And then when you add this 4 to the negative 36, you get negative 32. Okay? And now, since there is a negative under the square root, that now gives us a complex equation here. So we're going to have to put the little I right there showing that. Okay? And so now what we're going to do is we're going to go over here and we're going to factor out this. We're going to factor out 32. Okay, so let's see. We're going to write out the factors of 32 up here first. 32. We have 1 and 32, 2 and 16, 4 and 8, and I believe that is it. Okay, so out of these, the ones that will break down the easiest is 2 and 16. Okay, so we come over here, we write square root, so we have the square root of 2 times the square root of 16. The square root of 2 is just 2, so now we have 2. The square root of 16 is 4. And the square root of 4 can break down into 2. So 2 square root of 2 is our answer for the breakdown of negative 32. So we now have 2, don't forget our I that shows us that it is complex, square root of 2 plus or minus. Now we got to finish breaking down the negative 2 sixths. Okay, so when we plug negative 2 sixths into the calculator, we get 1/3, right? So we now have 1 plus or minus 2 imaginary square root of 2 divided by 3. And that gives us our answer, B. Okay, so for number 2, it says the radius of the circular base of cylinder A is 4 inches and the height of the cylinder is 5 inches. The radius of the circular base of cylinder B is 12 inches and the height of the cylinder is 20 inches. Which statement describes the relationship between the volume of cylinder B and the volume of cylinder A? Okay, so the easiest thing to do, probably be the first thing you should do, is draw out cylinder A right here, and I'm going to label it A, and it said the radius is 4 inches. And the height is 5 inches. Okay, and now over here beside it, you can draw a cylinder B. Label it B. The radius is 12 inches and the height is 20 inches. So write 12 and 20. It's a little small. And then, okay, so first you're going to find the volume of each of these. And the volume is base times height. So we'll write that out right here. Equals base times height. And to find the base, you're going to have to use pi r squared. So we'll put base of A. We know that B stands for base, so just write that out. That'd be easiest. Base of A equals pi r squared. Pi times the radius, which is 4 squared. 4 squared is 16, so that's 16 pi. 16 pi is 50.3 when you round it. So we now have 50.3 times 5, and that gives us 251.3. Okay, so 251.3 right there. Okay, so for B, it's the same thing. Volume equals base times height, and base of B equals pi r squared. So pi 12 squared, it's 144 pi, rounds to 452.38. 2.38. Okay, now I come back up here. Okay, so we have base times height. So 452.38 times the height, 20. So 20 equals 90.48. Okay, and now what we do is we read each statement and see which one is true. Okay, so the radius of the circular, A, the volume of cylinder B is 12 times the volume of cylinder A. So what we do is multiply volume of cylinder A by 12 to see if that's correct. So let's look over here. So 251.3 times 12 equals 3015.6, and that does not match. So A is wrong. You can go ahead and mark that one out. B, volume of cylinder B is 24 times the volume of cylinder A. So let's multiply 251.3 times 24. 6031.2. That also is wrong. Okay, and this the C statement says the volume of cylinder B is 36 times the volume of cylinder A. So let's go over here. 251.3 times 36 equals 9046.8. Okay, let's remember that. So we'll write this one is 9046.8. Statement D says the volume of cylinder B is 108 times the volume of cylinder A. So let's do 251.3 times 108. And that is way off, so that's 27,140.4. That's way higher. Okay, so correct statement is C, because it was 9,046.8. You can just round that up to 9,047, and this is 9,048. Okay, so the volume of cylinder B is 36 times the volume of cylinder A. Answer C. Okay, number 3 says, what is the solution for the what is the solution set for the following quadratic equation? And we have 2x squared minus 3x plus 4 equals x plus 3. So what we're going to have to do here to start is to set it equal to 0. And to do that, we're going to have to move this x and this 3 over to this side. So to do that, we're going to have to subtract this x from this side, so it'll cancel. So that gives us 2x squared minus 4x on this side. And then we're going to have to subtract 3 to get it to cancel, and then 4 minus 3 is 1, so plus 1 equals 0. Okay, now we're going to have to label these A, B, and C for them to fit the equation. So A, B, C. And our quadratic equation is, hold on just a second, opposite of B plus or minus the square root B squared minus 4 times A times C divided by 2A. And so there it is. And so opposite of B, opposite of negative 4 would be 4. So we have 4 plus or minus negative 4 squared minus 4 times 2 times 1 divided by 2 times 2. Okay, there it is. Okay, so now we're going to figure out what is under the square root. So we have negative 4 squared, which is 16, and then we have negative 4 times 2 times negative 1. Nope, not negative 1, sorry. Times 1, just 1. Equals negative 8. So 16 minus 8 is 8. Okay, so we now have 4 plus or minus square root of 8. And we know that 2 times 2 is 4. Okay, so now that we have this, the square root of 8 is just a weird decimal. So what we're going to do is we're going to plug this in on our calculator. First we're going to start by adding, and then we'll do the subtraction. So 4 plus the square root of 8 divided by 4 equals 1.71. So we'll write that right here, 1.71. And then now we're going to subtract. So 4 minus square root of 8 divided by 4 equals 0.29. Okay, so, oops. So our answers are 1.71 and 0.29. And we go over here and look at our choices. We see that D is the correct answer. Okay, so for number 4, it says identify each equation that has exactly two distinct real roots. And so to do that, we're going to solve using the discriminant. I'm going to have to get out some notebook paper because I write big and there's not enough room on this sheet of paper. Okay, so we're going to solve in each individual square. And we're going to use the discriminant. If you don't know what the formula for the discriminant is, it is b squared minus 4a times c. And if you're thinking that looks familiar, because it is, it comes from right here, the quadratic equation. That's the discriminant right there. Okay, so our first one is 3x squared minus 4x equals negative 7. So 3x squared minus 4x equals negative 7. And I'm going to go ahead and write all of these out so I can just solve them. So x squared is the second one, minus 2x plus 8 equals 0. The third one is 5x squared equals negative 6. And remember, we're going to have to set some of these equal to 0 since they're not. And the fourth one is 4x squared minus 9 equals 0. And the fifth one is 2x squared plus 3x equals 4. And the sixth one is x squared minus 5x minus 3 equals 0. Okay, now we're going to solve. Okay, so for this first one, we're going to have to set it equal to 0, which means we're going to have to add 7 to the left side. So we now have 3x squared minus 4x plus 7. Okay, and we can label them A, B, and C. A, B, C. Now I can write our equation, which is b squared minus 4ac. Okay, now we can plug it in. So opposite of, well, negative 4 squared minus 4 times 3 times 7. Okay, so we're just going to plug this into the calculator. 4 squared is 16, and then negative 4 times 3 times 7 is 84, and 16 minus 84 is negative 68. And remember, it has to be greater than 0, since that is not, since this, is not greater than 0, that does not have two distinct real roots, Okay, for it to have two distinct real roots, it means it has to be greater than 0, and that is not. So for the second one, it says x squared minus 2x plus 8. We can label them A, B, and C. This is already set equal to 0, so we don't have to do anything to it. Okay, so b squared, we'll write down our equation, minus 4 times A times C, and write negative 2 squared minus 4 times 1, since there's no number there and we assume it's 1, times 8. Now we'll just plug it into the calculator, show you. Negative 2 squared, if it's in parentheses, it's always positive, is 4. And then negative 4 times 1 times 8 is negative 32. And 4 minus 32 is negative 28. And negative 28 is not greater than 0, so that one is not. We can just go down here. We've done the first one. It does not have two distinct real roots. We can mark it out. And this one doesn't either, so we can mark it out. Now we're doing this one. 5x squared equals negative 6. It's up here. And we're going to have to set this equal to 0. And to do this, we're going to have to add 6 here, so it'll cancel. And then now we have 5x squared plus 6. And since we don't have a b term, we assume that it's 0. So A and C, so our b term is 0 squared minus 4 times 5 times 6. Okay, so go over here. 0 squared is 0. And then negative 4 times 5 times 6 is negative 120. And negative 120 plus 0 is negative 120. So negative 120 is not greater than 0. So this one doesn't have any distinct roots either. So we can mark it out down here. Okay, now we're on our fourth one, and this one is 4x squared minus 9 equals 0. Since it's already equal to 0, we don't have to do anything, but we notice that it does not have a b term. So once again, the b term in this is 0. So 0, I guess I could write down the formula. I didn't write that on the last one. B squared minus 4ac. Okay, so 0 minus 4 times 4 times negative 9. Okay, so plug that in the calculator. Once again, 0 squared is 0. Negative 4 times 4 times negative 9 is 144. Okay, so this one is 144, and it is greater than 0, so this one has 2 distinct real roots. Okay, so we can circle that one down here. 4x squared minus 9 equals 0. Has 2 distinct real roots. And this one, our fifth one, says 2x squared plus 3x equals 4. This was not set equal to 0, so we'll have to do that. So subtract 4 from this side, get 2x squared plus 3x plus, minus 4 equals 0. Okay, and we'll label them A, B, and C. So we have b squared minus 4ac, and so that'd be 3 squared minus 4 times 2 times negative 4. We have 9 minus, we have negative 4 times 2 times negative 4 minus 9. Oh wait, sorry. Let me try that again because I don't think I got that one right. 3 squared is 9. Negative 4 times 2 times negative 4. 9 plus 32 is 41. Sorry, I didn't mean subtract. Be 9 plus 40. 32. Sorry. 32 equals 41. And 41 is greater than 0. So this one too has 2 distinct real roots. Okay? Our sixth one, x squared minus 5x minus 3 equals 0. So we'll label them A, B, and C since we don't have to do anything. Okay, so b squared minus 4ac is our formula, and we'll just plug those in. So negative 5 squared minus 4 times 1 times negative 3. Okay, and so negative 5 squared is 25. We have negative 4 times 1 times 3. 25 plus 12. Oops. Negative 5 squared is 25. And then the negative 4 times 1 times negative 3 is 12. And so we have 5 plus 12. And that gives us 37. And 37 is greater than 0. So the sixth one has 2 distinct real roots. So the bottom 3 have 2 distinct real roots. That's our answer for number 4. Number 5 says, how far does a 23-foot ladder have to be placed from the building? Okay, so we see that this ladder is 23 feet, and this section of the building is 12 feet, and we're looking for this section to see how far away it needs to be placed. So to do that, we'd solve using the Pythagorean theorem. And if you don't remember what that is, it's just simple. A squared plus b squared equals c squared. Okay? And these are our A, B, and C terms. So A would be 12 squared plus b squared. Since we're solving for b, we don't have one yet, equals 23 squared. So that's 144 plus b squared equals, let's see what 23 squared is. Squared is 529. Okay, so to get b by itself, we're going to have to subtract 144 from both sides. So 144 b squared equals 29 minus 144 equals 385. Okay. Now we're going to have to find the square root of both sides. B equals, let's go over here to the calculator, square root of 385 equals 19.6. Okay, so B equals 19.6. This is B. Okay, and we come over here and look at our answer choices, and we see that it is D, 19.6 feet. Okay, so for number 6, it says you are given the square A, B, C, D, and then it says identify all true statements. Okay, the first one says if DB this line right here that I just traced equals 4, then BC, this line right here, equals square root of 2, and then this line DC equals square root of 2. Okay, now let me get my paper here. Our rules for triangles, if you have an isosceles triangle, then you know that the hypotenuse is always the length of the legs times 2. And the length of the leg times the square root of 2. So let's say if it was the square root of 2. So we have, if this was, let's just say this was the square root of 2. That means the hypotenuse is always the length of the leg times the square root of 2. So if the leg is the square root of 2, so we have times 2, then that is not right. So if that were true, then that would be 4 square root of 2. So this one is not true. We can go ahead and mark it out since it's not true. Okay, this one says if DB, this line right here that I traced, equals 10, then BC and DC equals square root of 5. That is not true. Because, like I just said, it would have to be 10 square root of 2. So that is wrong. If DB equals 14, then BC and DC equals 7 square root of 2. So come over here to the calculator. Square root of 2 times 2 equals, hold on just a second, it's not working. Okay, but it says if DB equals 14, then BC equals 7 square root of 2 times 2. It would equal 14 square root of 2 like the other ones did. So that is not correct. We can go ahead and mark it out. This one says if DB equals 15, then BC and DC equal 15 square root of 2 divided by 2. So 15 square root of 2 divided by 2 times 2 would equal 15 square root of 2 because the bottom one will cancel out. So this one is wrong. This one says if DB equals 4 square root of 2, then BC equals 4 and DC equals 4. That is correct because 4 times the square root of 2 would be 4 square root of 2. So this is the one we've been looking for all along. This one says if DB equals 5 square root of 5, then BC equals 10 square root, BC and DC equals 10 square root of 4. So if we take square root of 10, square root of 10 over 4 times 2, we would get 10 square root of 10 divided by 2. So this one is out. So our only answer for this one was the fifth option. If DB equals 4 square root of 2, then BC and DC equals 4. And that is it.